So welcome to Konstru Masterclass for AECtech 2023. Thank you very much all for 10 Thornton Thomas City employees today with 3 or 4 non-TT employees, which is great. A little bit of, well, before I get into the context of Konstru, I'll point out, so the Google Drive location is a folder called Konstru Interoperability. Everybody should have access to this. It contains 2 things. There's a folder here, which includes sample files, and there's also an exe. This exe will install Konstru for Revit 2023, which is what we're going to be working with today as an example. So if you'd like to follow along, please install that exe. Inside of this folder are 2 sets of files, as well as the PowerPoint from today. So there's a large set of Konstru Grasshopper examples. We won't be doing nearly all of these, but we'll look at a couple of them at the end of today. But those are sort of for you to take home and just sort of try it on your own. And then there's a sample models file folder, which includes a Revit file we'll be using today, as well as a SART model and a RAM model. So those are the files we'll be using today. This is the installation for today. The other resources I'll point out to everybody for those using Konstru for the first time is we have a Git book. This is a PDF manual. I'll throw a link to it in the chat here. That is searchable and contains sort of the most useful. It's the most useful place to find out things about Konstru. If you have a question, you can basically search it in here. If I want to find something, for example, how to complete installation. When you install Konstru for the first time, generally speaking, the plugin will appear inside of the software it's aiming for. So when you install Konstru for Revit, next time you launch Revit, you will have Konstru available. There is a slight extra step required for those using the CSI plugins, ETABS and SART. And the Konstru Git book has those instructions here. Essentially just requires you, once Konstru is installed, to add the Konstru tool to the plugin bar in ETABS and SART. So feel free to take a look at the installation instructions for Konstru from this manual, and feel free to reference it moving forward for the rest of the demonstration. Jump back to the slides. All right, so a little context here, moving backwards from now. So currently Konstru has about 2,500 worldwide users. Obviously, it's primarily structural engineers using Konstru. It was released to the global public in 2017, so some years now. Prior to that, it was an internal tool developed by Thornton Thomas City. We called it TTX back in the day. And this was one of the tools that was sort of chosen as valuable enough to turn into an external facing product. So Konstru has been around for quite some time. It's had many guises, but here we are. All right, so as I said, there's a manual online. This is the Git book, and it has documentation of many of the aspects that are relevant to Konstru use. I will say, having written most of this PDF, that there's more to know than you'd like there to be to use Konstru. Mostly that's because we link to many different platforms. But still, it can give you a lot of benefit and time saving, so it's worthwhile sort of understanding what's available. We also have a YouTube channel. So we have tried to document many of the sort of basic processes of Konstru, how to upload a model, download a model, compare a model, visualize data, etc. So if you jump to YouTube and search Konstru, you'll find a series of videos that will help you getting off the ground using Konstru. Okay, so what is Konstru? It is an interoperability software, primarily. It enables you to move BIM, building information models, and analysis models between different software. The software you see on screen in this diagram are the things that Konstru links to. So we have, from the top right, we have ETABS, which is a structural analysis software. We also have a client in Rhino and Grasshopper, which means we're able to create BIM models from Rhino and Grasshopper. Very critically, we have a Revit client, which allows us to create native Revit models from any of the other linked platforms. RAM structural system, is another software we link to. I should note here that Bentley RAM has quite a few different software. There's Concept, etc. The key thing that Konstru only links to RAM structural system. It does not link to RAM Concept, etc. So RAM structural system is the software. We also link to Tekla, which is a steel detailing software, which is great for projects that end up going through that level of sort of detail, where they have all the gusset plates added, and you can use Konstru to take your analysis model to Tekla for steel detailing. We also link to SAP, similar to ETABS, an analysis platform, and a classic but a goodie, Excel. So Konstru comes with an Excel client, which allows you to download any Konstru model, which could be a Revit, ETABS, RAM, Tekla model, into Excel and review the data there. Very useful for engineers. Okay, so it's a web-based platform, which means that when you upload a model to Konstru, you are adding information to an Amazon Web Server database. It acts as a central data repository, so you're able to send multiple models or information from different sources into a central data source, single Konstru model. As every time you upload from your local platform to Konstru, you are making a new version of the database. Once you have multiple versions of a model and in a database format, you have a project history. So Konstru does include the capability of comparing your current model to previous models. We won't be focusing too much on that today, but it is a possible workflow. It also includes a high level of control over the exchange of data between software. What this means in practical sense is something called filtering and profile mapping. It really lets you control at a very fine-grained level what information is going to actually pass between different software using Konstru. The two primary workflows that Konstru enable, and the two things that I really want people to come away with from today's course, is the ability to use Konstru to translate models. So basically interoperability. Take a model from platform A and turn it into a model in platform B. And the second workflow is model merging, which is, we'll do a demonstration of today, which is taking two independently developed models, two models that may have never translated with Konstru before. They may have been built by different companies, but Konstru enables you to compare those two files and then selectively translate information between them if you choose. This can be very useful for sort of end of stage projects where you've got a lot of metadata, things like camber and studs and profile sizes you need to get documented in the drawing set, but currently exist in an analysis model. So in a more sort of graphical way, the three workflows that I pitch for Konstru are a one-way translation. Konstru can take a Revit model and turn it into a ETABS model. Beyond that, there is the ability for Konstru to make round trips, which is where you start in one software, you translate to another software, you make changes in that software, and then you bring it back to the original software. We will do an example of that today. And many of the features of Konstru that we've built are aimed at trying to make that workflow easy. It's not really that easy, unfortunately. And the last one is model merging. So this is, as I said, sort of taking two independently uploaded models, comparing them, and adding information from one to another. Why do we build Konstru? For translation purposes. So it can do sort of two things. It translates models. So you can get, all the 3D objects from one software and have them appear in a different software. That's very useful in terms of time saving. But in a modern BIM environment, what we also need is all of the information attached to that model. So in a structural sense, from a typical steel beam legend, Konstru is able to translate the attributes in green ticks here. So size, the forces attached to an object, the camber, the number of studs, etc. We do not translate currently the moment connection symbol or the collector connection symbol, but everything else in terms of data on that legend, Konstru is able to move around. So this is the agenda for today. The first goal is going to introduce Konstru as a translation interoperability platform. We're going to, let's say, take a SAP model and translate that SAP model directly into Revit. We may, as an example, stop in Excel with some use of Excel rounding and factoring to our analysis results on the way to Revit. We'll also demonstrate how you can sort of go the other direction, where you can take a Revit file and translate it to, let's say, ETABS. And the key feature we're going to discuss here is the ability to repair the connectivity of the framing of the model. So whenever you move from Revit into an analysis platform, because Konstru will literally read the XYZ start and end coordinates of the objects, if those end coordinates are in a bad position in terms of things not connecting together, then you're going to have issues you have to resolve in the analysis model. So the goal is Konstru now includes a set of tools that should be able to very quickly repair any issues you have with the model before you translate. As part of that example, going from Revit to ETABS, we will do a round trip. So we will make some changes to that ETABS model once we've translated it across. And we will attempt to bring those back to Revit. And this is going to introduce two very critical stages in a Konstru translation, the mapping interface and the filtering interface. So we'll spend some time reviewing what those are for and why they were built to do what they do. After we've had a look at the one-way capabilities of Konstru via those two examples, we'll review the model merging feature. This is done entirely via the web app. So you'll be sort of uploading models from your local platform, doing a comparison on the web app, and then making changes to the objects based on that comparison. We'll probably have a break somewhere in there after model merging, and we'll finish out with some examples of parametric Konstru. So essentially leveraging the Grasshopper client that has been developed for Konstru to do a number of things. We'll look at how you can create a model in Grasshopper for SAP, ETABS, Revit, etc. using Konstru. We will look at the ability of the Grasshopper client to move models around. And this is sort of tied directly to the model merging workflow, where sometimes to merge two models, they need to be in the same coordinate space. Not every model is in the same coordinate space. And to move things so they are in the same coordinate space, we have some Grasshopper components to do that. So we'll look at that as an example. And finally, I'll show sort of a more cutting edge workflow that leverages Rhino inside Revit. So this is, again, this is not something I'm asking people to have installed for today, but I'm just going to demonstrate. Recently, McNeil, who released Rhino Grasshopper, put a plugin out that allows you to run Grasshopper inside of Revit. And what that enables us to do is to actually bring in any Konstru model to Revit. So you can open a SAP model in Revit. You could open an ETABS model in Revit. You could open a RAM model in Revit in this case. And I'll show an example of that to finish out the day. Okay, before we get into the first demonstration example, I just want to get a little bit of an idea about people joining the call. I'm assuming everyone on the call is a structural engineer. Do we have any non-structural engineers participating today? Okay, well, that's good to hear. It'll mean that almost all of the things I talk about are going to be relevant to you. But anyway, let's get right into it. Oh, actually, there's a couple more slides here. Get going. All right, so first of all, some feedback from different engineering firms who are using Konstru. You know, the interesting thing here is that these are some of the competitors for Thornton Thomas City, but they're all using it. I try to pitch Konstru as a time-saving mechanism here. Modern structural engineering practice usually involves building a lot of analysis models. You can try to limit it if you can, but as we're delivering a lot of our projects in Revit these days, those analysis models can be leveraged into the final product, which can save a lot of time. So we're going to start with interoperability, taking a model from platform A and turning it into platform B. And why do we do this? Like I said, mostly to save time not rebuilding models in multiple software. How does Konstru achieve this? You essentially upload your model to a Konstru database, which, as I said, is a web-hosted secure cloud server. And then you're able to download that model into a local platform via a locally installed plugin. Why would you do this? Why did we develop Konstru? Well, this building is an example where things change. Building projects change week to week. The size and shape of this building started on June the 15th with only 15 floors, and by the 23rd, it had 34 floors. So for a structural engineer who's looking at this project, unfortunately, that means making changes to their analysis model to update to match the new geometry positions. And with such rapid changes, there's no time really to build a model of this scale effectively. So Konstru can help with this. In this case, a Grasshopper script was developed that were the building to change shape, new floors, etc., were created in the analysis model. The other benefit of Konstru for interoperability is the fact that modern buildings usually are not designed in one analysis software. So there are usually multiple analysis software involved. This is a project in the New York region on Roosevelt Island, Cornell Tech. And essentially in this building, two different analyses at minimum were being run, as well as a third model that was being used to generate drawings for collaborators. So there was a RAM model used for the floor framing of this building, vibration and gravity, etc. There was a SAP model generated to analyze the facade truss system. And obviously, like I said, we had a Revit model that was being used to create all the drawings and details, and also allowed us to actually make the collaboration step, right? All of the structural analysis information can then be shared with your clients because they won't have licenses for the other software you see here. And I'll mention briefly now as well the Konstru client before we get into an actual practical demo. So it may not seem like much, but we have when you install Konstru, you'll get an Excel client, which means whenever you launch Excel, you now have a little Konstru tab here, and you'll have the ability to then download any existing Konstru model into Excel. So this is a two-way process. You can actually make changes here. In the example we'll do today, we'll actually do some rounding of forces. Once you download the file, you get basically a new worksheet for every object type, and you'll see that all the parameters are available to us here. You can actually make changes, add macros that upsize things, specify material sizes, etc. Any editable cell can be changed in this case. All right, so time for a demo. Like I said, the two one-way translations we're going to focus on today is moving from a SAP model into Revit with a stop in Excel. And we'll also do a Revit to ETABS sort of round trip that includes framing repair. So these two files, the SAP model and the Revit file, have been added to that Google Drive folder. If you'd like to follow along, feel free to download those two files. If you would like to use your own model, like I said, you're completely able to on your own end. There's no critical need to use the example files that I'm going to show today. Okay, so with that said, I think we'll start with the Revit to ETABS framing repair round trip, and we'll finish with the SAP to Revit with a stop in Excel. Before I get going, are there any other questions I can address? Okay. All right, so I have open here Revit 2023. And okay, so which models do I need to download from the Google Drive for the demo? Inside of this folder, AECtech 2003 mini masterclass, there are sample models. The sample models folder includes the Revit file that I have open on my screen. So in here we have a Konstru 2023 example file. That is the Revit file that I have open here, this model. The other two files that are going to be useful for you to extract is going to be the SART model. It's a very simple model. The S2K file is the key thing to download there. There is a lot of, sorry, the SDB file, my apologies. SART sort of explodes the file into a bunch of file types for you, unfortunately. So that's why that folder looks a little messy. So the key one is the Revit file, which is the 2023 Revit file that I just pointed out at the bottom of that folder, which is this model here. Okay, so we're about to make a one-way translation from Revit into an analysis model. The first thing we want to pay attention to is the position of the geometry in the Revit file. And when I say the position of the geometry, I am referring to the possibility of two things. And I may actually, I'm going to leverage the Git book here. So I'm just going to search Analytic, and it's going to give me a page about Revit and that analytical model review, right? So this is something to know before you upload, basically. And what I'm pointing out here is that Revit includes inside of itself two representations of the position of geometry. There is what we call the Revit physical model and what we call the Revit analytical model. And the key thing to know here is that Konstru is able to access both geometric positions. Let's have a look. Physical versus analytic, I think is what I'm looking for here. Geometric differences. Okay, so Revit includes two different representations of geometry. You can imagine it being this sort of thickened 3D shape for a concrete column or beam, but also the centerline position. This is a plan view here of the column, which in this case is just a blue line, which ignores the thicknesses of the material, which are essentially analytical properties in this case. So what you usually have in Revit when you're making drawings is what you see on the left. What the analysis model for this really wants to look like is something like this, where everything's skewed and the thicknesses are ignored. But Revit's smart enough to actually leave the physical objects in the way that you modeled it, and to actually then kink the analysis objects so that connectivity is maintained between the objects. So first of all, Revit's very smart for doing this. It can be very useful for maintaining connectivity in complex particularly concrete structures with a lot of thickness involved in the objects. But what that means for Konstru is that because Konstru will literally read the XYZ position of the endpoints of the frames, we need to make sure that we don't have a model that looks without connectivity. We don't want to have a model that's not connected. The most obvious example that I like to point out to people is a brace frame condition. So this here is an elevation of a brace frame where we have two columns either side. We have a beam across the top, and we have a brace connecting from the bottom of a column to the middle of the beam above. Revit will automatically, at the base, connect the analytical endpoint and the physical endpoint to the same position. They're coincident at this point. And just to be really clear here, when I say the physical position of the object, I mean the depth of the beam, but most critically, I mean wherever the blue dot is. That little blue dot in Revit is describing the physical endpoint XYZ position. So we've got coincident condition at the base, but you'll notice at the top here, where the beam is connecting to, where the brace, sorry, is connecting to the beam across, that Revit will automatically, by default, connect the physical endpoint to the centroid of the beam, and it will connect the analytical endpoint of the brace to the top center justified position of this beam. The reason it does this is because the analytical position of the beam is currently also top center justified. You can just see here the red and green pointing out where the analytical position is. So there's a gap that gets created. The reason Revit does this is because the physical object is looking to be positioned for gusset plate detailing. If I was wanting to come in here and apply a gusset plate to this brace and the one that connected across, then the coordinate position for the steel object should be the middle of the object. But if I wanted to analyze this, this would be a gap. There would be an issue and this beam would not, brace would not be connected to this position. So hopefully this describes to you sort of why Revit maintains two representations of the geometry and some of the things that Revit will do by default to those positions to maintain what it believes to be a connected state for the model. This can, obviously this applies most specifically to framing objects. Framing is the thing that will generally have the most sort of connectivity issues. It also can relate to floor objects in terms of how you set up the Revit file. So analysis models want flat floors with all the beams and the floor object at the same elevation. Revit models tend to want them underneath each other or above the other. So the floor is usually above the beams. There's many ways to sort of set up your model in Revit to achieve this, but the real goal here is to make sure that your framing is flat and connected. You can choose whichever level you like really, but ideally you avoid having to add a lot of offsets to your framing to push them under the slab. The suggestion we make here for Konstru users is when you're building a Revit model, it can be very useful to have a level that hosts the framing. So basically a top of steel level in addition to a top of concrete level. By hosting the framing at the top of steel level, you're going to guarantee that the Revit analytical model will be in better connected shape than if you were having it hosted to a floor above. Okay, so if you face these issues, the next question is, well, how do I fix it? And so the latest version of Konstru includes a new plugin, which will allow you to review those issues and then repair them before actually making the first translation. So in this model that I've provided, the sample model I have, the first thing I've done is I've turned on graphically using the visibility graphics menu, that's VG. I've turned on the analytical model categories. So that's why you can sort of see in the background here that we have an analytical brace position as well as a physical brace position. Now, this is technically the same object, but it has two geometries. In this model, there could be a very good reason why you might want to position the brace here. There could be a doorway, for example. But for the analysis model, we may want that to be connected. So Revit includes two descriptions of the geometry. That's the first thing to understand. Konstru is able to access both. So if I was translating from Revit to an analysis software, which we're going to do now, I would want to make sure that the geometry was as well connected as possible. However, if I was translating from Revit to Tekla, where the steel gusset plates were going to be detailed, then I would want to make sure I was able to extract from Revit the blue dot positions, because that is the relevant end coordinate for a steel detailing model. All right, so Konstru can extract both. In this case, because we're going to analysis, we're going to repair the analytical model. If I use visibility graphics here in Revit, I'm just going to turn off the model categories so we can really closely review what we have in terms of the analysis geometry. As you'll notice, first of all, straight away, this looks more like an ETABS model than the original Revit model, right? We've got single surface floor objects, analytical panels. We've got single line frames for the framing objects, and then vertical surfaces for the analytical wall objects. And it should be pretty clear just from sort of zooming around the model that we have some issues here. First of all, we have some framing that is not planar, that is not connected to the level it's hosted by. As I said, we have a lot of braces in this model that are not fully connected to the beam position above where we want them to be. In this case, these are connected to the beam above, but what I really want is them to be all connected at the center, as a chevron brace should generally be. So issues with the model. We also have over here some sort of framing that's not extended. So this frame is far shorter than it should be to hit the edge of the slab. So multiple issues with the analytical geometry in this case. All right, so the latest version of Konstru, which you will be able to install from that exe that I've provided, is going to include framing repair. And that's what I'm about to demonstrate now. This is a pre-process that we suggest you apply to make sure the geometry is in a good state before translation. All right, I'm going to launch framing repair and we'll talk through the steps involved. So the first menu you're going to see is which objects from the Revit model do you wish to repair? So we have selection options. We could use all the framing in the model. We could use an existing selection set if we had one available, or we could use an active group, right? So let's try an active group. If I grabbed just these objects here and launched framing repair, I can use the current selection, right, as an upload. So if you want to repair the whole model, you can use all framing, but it's also possible to just repair small regions if that's what you're aiming for. I'm going to just deselect that group in this case, and we'll do the whole model. So framing repair using all framing. The next thing to be wary of in this menu is the ability here to choose which geometry you wish to repair. So as I said, there are two options. We can repair the analytical model or the physical model. There are some occasions where you may want to actually make adjustments to the physical model using framing repair techniques, but most of the time you're going to be repairing the analytical model. You'll notice that currently it's pulling in all the levels in grids, which will be relevant once we get inside the framing repair tool. So use all framing, analytical model. Once you click OK, you'll get a pop-up that runs in front of Revit. So this is a small window which you can adjust the size of. And what it's going to show you straight away is a review of the connectivity of the frames that are present in this file. So on the right of framing repair, we have the visualization options. I can choose naked nodes, node connectivity, similarity, repair type. I also can increase the node size. So show me the red nodes, the disconnected nodes as larger. And again, this is pointing out what we sort of instinctively could see from the Revit model. We've got quite a few frames that aren't connected here, with some that are. Below the visualization options, there'll be a list of the total number of unconnected nodes versus connected nodes. The goal of the operations we do here in framing repair is to reduce the number of unconnected nodes. That's our goal here. So naked nodes, obviously red and green. We can look at things like node similarity. Node similarity is saying, I want you to show me any nodes that are within a certain distance of each other. So at the moment, every node that is within 1.4 feet is being called out. So some nodes are going to be red naked nodes, easy to discern. This can be a nice way to find out where there are nodes that are close together, but not quite connected within, and what distance those nodes are from each other. So just an interesting way to review the model. So for the most part, we're going to be concerning ourselves here with reducing the number of naked nodes. So on the right, we have visualization options. On the left, we have repair mechanisms. So what I'm going to do here is I'm going to add a series of repairs to this model to, like I said, reduce the number of naked nodes. These repairs should be thought of as sequential. So we have a different set of repair types. We have merge with intolerance, snap to date and work point, snap to plane, trim and extend, and pull to edge. Let's throw down a snap to plane first. So when I click add repair, you'll see a new repair has been added to the list. And in the 3D view, I will get a series of blue planes indicating at which levels are currently going to be used to snap framing to. So I have the ability to change the tolerance, the distance at which any frame close to that level will be snapped. So let's put this at 3 feet or so to be sure we snap everything. I can also actually specify which levels are being used. So these are all the levels that are present in the Revit file. You can see at the bottom, the TOF probably doesn't need to be used because there's nothing down there to repair. So I can actually uncheck that and it'll remove that level from the set that are being used to repair the file. Okay, so I've sort of set up the repair the way I'd like it. I've only used one repair method right now. As I said, these can be set up sequentially. But let's see what happens if I actually click run repair right now. If I click run repair, what you'll see is in the preview window, snap to plane has been applied to the model. Our number of unconnected nodes has gone down to 27 now. You can see it has done a pretty good job of snapping all those frames that were out of plane to the plane. But there are still more repairs that we need, right? We have a need to extend these beams to their edges, et cetera, et cetera. So that's where setting these up sequentially is going to be really nice, right? So next, what I can do is say, after snap to plane, I want you to trim and extend by, let's say, 4 feet as well. If I click run repair, it's now going to do the snap to plane and then the trim and extend. So as you can see, we've gotten to a point where we're down to a limited number of red nodes here. In this case, it looks like just one trim and extend hasn't quite made it, and that's probably based on the tolerance. So if I was to push this up a little further to, let's say, 5 feet, run repair. All right, great. It captured that last frame that wasn't quite extended and has pulled it into this position. So this might look pretty good as far as repair goes, but what I would point out here is that even if something's connected, it can still be in the wrong position. And what I'm going to point out here is my brace frame. So as you can see, it looks like really only the top chevron condition is connected in a nice position in the middle. This is a case where my snap to plane has done a good job of grabbing all the points nearby and snapping them to the plane, but it hasn't defined that I want them to snap to the midpoint between these two objects. So I'm going to add another repair, which I find very, very useful. It's called the snap to datum work point. So theoretically, what a datum work point is any two places where a grid intersects a grid. So in this Revit model, there is a grid system on the ground, usually at the main columns. And what framing repair is doing here is wherever it sees two grids in Revit, it intersects them and makes a node. It then takes those nodes and it projects them across every level in the file. And this is what we call a datum work point. It's essentially a small sphere in 3D space with a radius. And any node within inside of that sphere will be snapped to that position. So if I bump up the size of the sphere here, you'll see that the graphic's going to get bigger. And this is going to help me decide whether the radius I have is going to be enough for the job. And what you'll notice is I don't currently have spheres being generated at the midplane, which would be a great way to repair all these issues here. As I said, framing repair leverages the grid objects from the Revit model. So what I'm going to do to make these repairs is I'm actually just going to close framing repair. This is all just temporary. This is a review stage still. I'm going to jump back to Revit. And I'm going to add an extra temporary grid at the mid span between this chevron brace, just so that I can create that sphere and subsequently repair all those brace frames automatically. So it just requires sort of temporary addition of a grid to that place or any other position in that matter that you wanted to create a date and work point. And then we'll use the analytical model, all framing. We've already sort of done our review. We just have to put our repairs together again. And in fact, this might be an interesting way to sort of point out how date and work points work. So previously we did snap to plane, then trim and extend, and we were going to do date and work point last. Let's try date and work point first in this case and see how it can be very useful in repairing multiple issues at once. So for example, this corner down here, we've got a column and two beams that are nearby but should extend and attach to it. So trim and extend would be a valid way to fix this, but we can also use date and work points. If I up the tolerance of that sphere far enough, all those nodes inside of that sphere will now snap to that position. The same thing is true now on the other side. Along the brace frame, you can see here that a series of spheres, work points, has been generated. And as long as my tolerance is big enough, it's a bit of 4 just to be really certain, it should capture all those nodes inside of it and snap them to its centroid. So let's try running repair just using snap to date and work point in this case. And you'll see that over here in that corner where we had issues, that's all those frames have been repaired at once. Obviously, we still need trim and extend because there are no date and work points for us in these regions where there are no grids. But we have gotten a very nice, clean brace frame condition. It's a bit hard to see here. But all of these now connect to the exact midpoint of that particular bay. I'm just going to add in the last two. So we do want to add our snap to plane here as well. So let's make sure we capture all those frames that are above the plane, and then we'll trim and extend. And then once I click run repair, it's going to apply all those fixes to the file. And as you can see, we're still a little short here. So I guess that was 5 feet trim and extend. We're now down to only 8 unconnected nodes. And you can see graphically, a column base is considered unconnected. So we have some column bases that don't have things connected to it, but everything else is green and repaired. So at this point, we have the option to update the analytical model. So as I said, this is all sort of a pre-processing stage. You're just reviewing, making sure you like what you see. If I wanted to now update the analytical model, I would click this button, and this will actually go back to Revit, and it will then update the position of all those analytical objects to match the framing repair position. So if I turn off the physical objects now, you'll see that we have a very nice clean brace frame condition for all of our nodes, for all of our braces up here. We also have no frames out of plane. Everything is flat and planar to the floors. And all of the frames now connect all the way to their endpoints. So at this point, this model is in a good state for analysis, in particular, obviously, the analytical position of the objects. Just to be clear, we did not adjust at all the physical position of those objects. So whilst our analytical braces are now connected to the center, we did not move at all the physical position of the objects. It's entirely possible to do so if we wanted to. So let's try an example where we use a selection-based upload. If we wanted to repair all these braces, these physical braces to the center, I could simply make a selection. So I'll just grab, let's say, these 4 in particular. Come up to Konstru, go to framing repair. In this case, I'm going to use the current selection, but I'm going to use the physical model. Click OK. We're going to get a much more limited preview here because we only have a selection of 4 objects. So it's really just the 4 braces that we're concerned about. And I'll add my date and work point, which is going to bring up all those work points we saw before. And all we need to do here is we just need to increase our snapping size to make sure we capture the size necessary to repair those braces. So I think about 3 feet is going to do it. We'll click Run Repair. All right, so we've got connectivity of those braces at the top, and then we'll update the physical model for those particular braces, and those have now been repaired to that position as well. So it's up to you which position you want to repair to, but as I said, for the most part, what we're doing here is repairing for the purposes of analysis. So the thing we're focusing on is the analytical model. Any questions on that process? Okay, we'll keep moving. All right, so Konstru translation, you need to create a Konstru model. That is done via the web app. So I'm going to jump up to a browser here. I am going to be using Chrome. Highly recommended that you use Google Chrome. When using Konstru, it'll just run a lot better than whether you use Edge or Firefox. The other thing to note is I often end up using Konstru in incognito mode, which does have the benefit of sometimes avoiding some login issues you may face using Konstru. All of this is to say that the next place you want to go is the web app, app.konstru. So if you are facing these login issues, feel free to follow this link to find out some instructions. But here we go. So this is the web app. What you see here is a list of models that I've been working on. And on the top right, you have the ability to create a new model. And this is what we're going to do to facilitate this translation from Revit into ETABS. So I need to give the model a name. We'll call this Repaired Analytic Geometry for ETABS. AECtech. So what we're creating here is an empty container. We're creating a place for us to add information to. So we now have a model called Repaired Analytic Geometry for ETABS as part of our Konstru organization. There's nothing here to see. You can sort of run a video if you want to learn about how to upload. But with that model created, I'm going to jump back across to my Revit instance. And from the Konstru tab, I'm now going to launch Konstru for the first time. So the Konstru interface will look very similar for all the platforms you're going to be working in. Essentially, it's this. It is a list of the models that you have access to, that you have created. So you should get a little preview of the model in this little view, but you can see here there is no model uploaded to this one just yet. So this is the file I'm going to choose, the one I just created, Repaired Analytic Geometry for ETABS. Click yes. And then we have another option, another little interface to review here. So we have a big button that says Upload to Konstru. We also have the option here to change the filter. In this case, I am going to choose the recommended upload from Revit. We'll talk about filters in more depth in a minute, but for now, I'm just going to make sure I choose the recommended upload. The other critical step to pay attention to in this interface is the little checkbox you'll see at the bottom there. Use analytical geometry of beams, columns, and braces if available. This is the portion that allows Konstru to access the analytical position as opposed to the physical position. So if I did not check that little box, then Konstru would go into the model and it would read the blue dots, the physical position. Once I check that box, Konstru is going to read the analytical model, which, as we've just seen, is the repaired condition in our case. So I am going to want to check that box on upload. One thing to note, when you check that box, you'll see a little pop-up here. Since you activated analytical geometry, we recommend turning off download geometries into Revit. Click here to adjust filter settings. What this is pointing out is that the Revit API, whilst it lets us read the analytical position of the geometry from Revit, will not let us update the position of those objects into Revit. So by uploading the analytical geometry, you are sort of automatically preventing updates to those positions on the way back. Hopefully this will be more clear when we look specifically at the filters. All right, so with this button checked and the recommended filter added, I'm going to upload to Konstru. I have an option here to upload a selection of objects. So if I wanted to, I could have uploaded just a portion of this model by either having a group present already in the file or just basically having a selection of objects before I launch Konstru. So I am uploading the full model in this case. If I did have a selection of elements, I would be asked to either use it here or choose from one of the existing groups. I think actually just because this is useful, I will just show you how that works. So if I did want to, this building obviously has a concrete base and sort of a steel podium on top. If my goal was to use Konstru to just translate the concrete portion across, what I could do is I could make a drag window just like this. And when I launched Konstru and I checked that box to upload a selection, it would only use these objects and it would ignore the rest of the objects in the file. The other way that you can do this is you can actually save selections. So in this case, I may say, save this and call it the concrete podium. And I may save the top portion as the steel tower. So we'll just do a drag selection around those objects. And we'll grab those columns as well. And we'll save these as steel tower. So these are selection sets in Revit. It's not technically a model group per se. It's using the selection set feature. All right, so with those selection sets added, we'll just do the same process again. We'll launch Konstru. We'll choose the file we wish to upload to. Can you go, all right, let's just have a look. Can you go back from repair? You could undo. If you really needed to, you could basically in Revit, it's a process we applied. So there is the possibility of undoing the changes that framing repair made to Revit. But that's about it. The key here is that the change we made with the analytical model, not the physical, undo is possible. Good suggestion from Jason there. If you're really concerned, you could save a copy of the Revit model before making the changes. That's entirely possible. Next question, when choosing a filter, I only saw one. Yes, we will be adding some more of our own filters eventually. When you first use Konstru, you only have the recommended available to you. Okay, so repaired analytical geometry, that's the one we made. We're going to upload to that. We're going to make sure we use the analytical geometry in this case. We're using the recommended. And if I now click this button for selection, you'll see that I can actually upload either the concrete podium or the steel elements, whichever one I choose, right? So this is where adding selection sets inside of your Revit model can really help make uploading to Konstru much simpler. I'm not going to do a group in this case. I'm just going to do the whole model. So we'll do first upload, update Konstru. Okay. So what's happening here is Konstru is going to read the Revit model. It's looking at the Revit model you have open. It's looking at all the objects present. And the next thing Konstru is going to do is have a review interface. So this step is telling you what's about to happen. Well, it says new. What this is telling me is that Konstru is about to add a bunch of new objects, grids, levels, columns, beams, floors, etc., to the Konstru model. Currently, we're looking at by status, but I highly recommend reviewing the by type interface. What this is now showing us is that Konstru is about to upload 10 levels from the Revit file. It's going to upload 8 load patterns, 7 grids, columns, beams, floors, braces. The next thing you'll see is a little icon, a little filter icon. And what this is showing you is that currently this object is allowed. It is the current filter that we have, which is recommended by this drop-down menu, is allowing that object to be uploaded. If I scroll down a little further, you'll notice that eventually I run into some objects that have a red circle. And even further down, the third sort of icon you'll see here is a filter with a red circle over it. So to describe the three, the filter icon means the object is allowed. The red circle means the object is not allowed. And in this case, it's not allowed because the object type does not exist in Revit. As we're dealing with an interoperability software, some object types exist in some platforms, but not in others. So, for example, we have a Konstru node object type, which can be very useful if you're working in analysis platforms because they usually have a joint object that has properties. Revit does not include a node type. So this is why you'll see the filter icon with the big red circle. The other option is this icon here. And this is a case where the recommended filter is preventing this particular element from being translated by Konstru. As you can see from my drop down, yours is going to look a little different. You'll just have the one filter. I have lots and lots of filters. And I think hopefully the name of the filter you see here will start to give you an idea about how I use them. Things like no floors is one of my filters. And if I was to turn on the no floors filter, you'll see that all of a sudden I'm reading all the objects as before, but it's ignoring the floor objects. So no floors from the Revit model would be uploaded as part of this upload. So again, this is the ability to control at the upload point what object types are being uploaded, which can be very useful when you've got very big, complicated files with lots and lots of things in them. So again, I've switched back to recommended, and the floor objects are now once again being allowed to be uploaded. Okay, so I'm just going to, again, when you're uploading for the first time, it's a good idea to pause here and have a look, but it's not critical, right? Because everything should be sort of reasonably simple here. So once you click looks good, proceed, Konstru will read the file, and then it will upload to the web database, and you now have a Konstru model. So online, you can view the model by launching it directly from this icon. It'll probably also be open in the background where you opened it before. And if I refresh now, you'll see that those objects have been uploaded to Konstru. So here is my repaired analytical geometry for ETABS. Object types listed on the left. It's a 3D model. You can spin it around. You can click on things and review their properties. So for this particular column, the material we read was steel ASTM A992. The profile was W14 by 26. Et cetera, right? So we have all those BIM properties have been captured, concrete material profile, during the upload. The web interface is mostly here for review of the model. So under the Visualize Elements tab, you can visualize by multiple different categories. So I could be visualizing by type, and this tells me what are beams, what are columns, what are braces. I can visualize by material. And again, this is telling me basically these are the materials that were captured and applied as part of the upload from Revit. We've got something called concrete masonry units, metal deck, concrete cast in place, ASTM A992. You can also visualize by profile. So this is again the sizes of the shapes that were uploaded. Rotation, and it even actually lets you go down to specific attributes. So any attribute that was present in the Revit model could now be visualized for. In this case, I don't think we have any comments on any of the objects, so there's actually nothing to show. But if there were comments present in the Revit file, you could visualize by those attributes. We're going to just start out by looking at the default view. You'll notice we've got all of our objects. You'll notice also that all of our positions are the analytical positions, so well connected to the floor above, and everything flat and planar. All right, next stop on this one-way translation is an ETABS file. So I'm going to open up an ETABS model here. All right, and I'm going to use a new model. And we're just going to use a new blank file in this case. All right, so here is our empty ETABS model. We'll just close the plan view, leave the 3D view open for now. Okay, so as I said, ETABS and SAP will require you, when using Konstru for the first time, to add the plugin. These are the instructions I mentioned that are documented on the Git book. But essentially, I'll leave the screen here just for a second. All you need to do basically is add a new plugin, give it the menu text Konstru, and then browse to a specific folder located on your P drive. That path address is part of the documentation online. The one caveat I would say is for the sharp-minded out there, you may have noticed I'm currently using ETABS 20. But pointing at the ETABS 19 DLLs. So as it stands, the 19 DLLs will run both ETABS 20 and 21. So you are able to point at that location and still have Konstru work. So once I've added it, you'll get a Konstru button here inside of your ETABS model. The exact same process applies for SAP. And we're going to be given the same interface as we saw previously. So here we have the model selection. We need to choose which of the Konstru models that we have in our organization we wish to download into the ETABS file. So you can see there's my repaired analytical geometry for ETABS, the AECtech demo. Okay, so our interfaces are going to get a little more complicated now, and we have to pay a little more attention here. First of all, we now have two buttons. We have an update to Konstru or a download to ETABS. Our goal here is to download to ETABS. The reason the update Konstru button is and both are present is we could technically update the Konstru model with an empty ETABS file, right? That's possible to do. Our goal here is going to be to download to ETABS, and we're going to use the recommended filter for the time being. Just like on the upload, the first thing Konstru does is it presents you with a review interface. And the goal here is to describe to the user what's about to happen. What am I getting when I download this Konstru file into ETABS? So the by status tab is not going to look too interesting just yet because it's still a bunch of new objects being created. Levels are being added, columns are being added, beams are being added, etc. to the ETABS model. If we look at the by type menu, you can see here that levels are being downloaded. In this case, the recommended download from Konstru to ETABS filters out load patterns. So this is an example of where the recommended filters came from. Why does Konstru have recommended filters? Well, we recognized that most users, when downloading a model to ETABS, are going to want to use ETABS load patterns. You may have noticed that Revit actually includes some of these objects now. When we uploaded from Revit, we did actually capture some load patterns, right? So there were 8 load patterns already in the Revit file. And what the recommended filter here is just doing is saying, you know what, it's most likely you don't want those Revit load patterns inside of ETABS. So the recommended filter from Konstru to ETABS will filter out those objects. I think the next one you see here is grids. This is a quite critical one and rather unfortunate, but the ETABS API, the program interface behind ETABS, does not let us create grid objects through Konstru. So even though we were able to upload from ETABS those grid objects, we are not able to create them as part of this download. We are going to get our columns, our beams, our floors. In this case, foundations are again another object that are not supported inside of ETABS, so we cannot download them even though they exist inside of the Revit model. And then there's a whole bunch of filtering going on at the bottom based on the recommended download. The other thing I want to mention here is this little checkbox. Again, an important one to understand. This allows you to delete existing elements that may be in the ETABS model. And the reason this is relevant, I'm going to check it here. You'll notice all of a sudden, if I was to delete existing elements, Konstru is saying, hey, there are 6 elements in this file already that I'm about to delete based on that checkbox. And these are the stories. So an ETABS model by default needs to include levels, stories, but our goal is going to be to use Revit to drive those levels as they're going to be created as part of this download. And I don't want duplicates or misaligned levels, so I'm going to work to delete the objects that are already present in the file. So checking that box can be very useful on the first time you download. Obviously, in future downloads, you would be unlikely to want to delete everything. But in this case, it is the best way to get rid of things that might be in the file that you don't want in the file. Okay, so having checked the review interface, seeing what I'm going to get, thinking that it looks pretty good. The next stage, and this is slightly different than you saw on the upload, is what we call the Konstru mapping interface. So just before we were looking at filters, now we're looking at mapping. And what is mapping? Mapping is an interface we've developed essentially to try and address the fact that Konstru links to different software. And generally speaking, those different software will have different naming conventions for their material properties, their profile properties, and other sort of very specific attributes. So the first tab we're looking at here is the materials tab. You'll notice there are also an areas tab, which is walls and floors, and profile sections. But we'll start with materials. The first column is called the incoming type. This is the material as it was read from the Revit file. So in Revit, there are objects who have a material called concrete masonry units. There's concrete, cast in place, gray, metal deck, steel ATSM, and an unknown material. Then the next column you see is the assigned to. Essentially, this is Konstru reading the available properties in the ETABS file and trying to find an appropriate match for the incoming property. So on the far right, this list over here is the available materials that are in the ETABS model that we have open. So this is a rather limited set of materials because it was a blank ETABS model. It included 4,000 PSI material, a tendon material, rebar, and a steel material. So in terms of the interface, when the Konstru interface has a grayed out tab here, Konstru has looked inside of ETABS and tried to find a match. So for concrete masonry units, it apparently found A992 FY50, which is not really a good concrete unit, right? So what we're going to do is we're going to make a change to this assignment and say concrete masonry units in ETABS should be assigned 4,000 PSI as a material property. In the case of concrete cast in place gray, it did actually find an appropriate material. So it matched the word concrete and found 4,000 PSI beneath. For metal deck, it went and grabbed the steel property. For steel ASTM, it grabbed the right property here. And it also applied a material property for those unknown. So our goal in this one-way translation is to have an ETABS model that's ready to go, ready to be run, has appropriate properties in ETABS, has appropriate sections, etc. So that's why in this case, we are assigning ETABS materials where Revit materials are being imported. This becomes even more sort of interesting when you imagine it going beyond material properties and into profile properties. So when we uploaded from Revit, we had a couple of floors and some walls. In Revit, those floor objects, their name was 3-inch LW concrete, 2-inch metal deck. There was also a wall object called CMU 12-inch. Now, on the right, you can see that in this case, it's not mapped, doesn't have a grayed out property. Konstru has the ability to create new properties in your analysis or Revit model. So in this case, because the ETABS model does not include something sort of close to these two types, Konstru can create those objects from scratch. So you are able to let Konstru create new if you like, or alternatively, I could say, you know what? I don't want Konstru to make a CMU wall. I just want to assign it to the existing wall property that's in the ETABS file as it stands. Right, so this is me managing the differences between a Revit file naming properties and an ETABS file naming properties. In a perfect world, they both have the same name and Konstru would match them. And this is what usually happens with profiles. Profiles are the one case where the libraries across different platforms are quite similar and named the same way, generally speaking. So what's happened here is Konstru has seen that there is a W14 by 26 uploaded from Revit. And in the existing ETABS library, there is the entire W library available, or quite a few of the pieces. And so what it's done is it's gone through and it's found that a 14 by 26 exists in this library. Here it is. And it's assigned that property to that object. So this is a case where the name in Revit and the name in ETABS match. Konstru will find that match and you're good to go. But obviously there are instances where the property may not exist. So let's say for the concrete beams that were present in our upload from Revit, 12 by 24 and the 30 by 30. There are no concrete beams in the ETABS model. So we could either let Konstru create a new property, or we could assign it to one of the existing concrete properties. So let's say that 12 by 24 should really be that concrete beam. Right, so whilst this seems like not an important place to pause and sort of review, it's very critical to understand what Konstru's about to create for you to make sure that the model that you're creating is the most useful in that software. So I'm happy with my mapping in this case. I will say that the intention of this is that it's done sort of one time for a project. The goal here is that once you've set up a mapping, you can save that mapping. And if you were to do this again, you would be able to load that mapping. So it's remembered next time you come around. Let's click OK. So once you click OK from the mapping interface, Konstru is going to do its thing. It's now going into ETABS and it's building ETABS objects based on the properties as it has from the Revit model. The last thing you'll get as part of the translation is going to be this transaction log, which is going to refer to what just changed on the download. So it told me, guess, hey, heads up. You had a material called concrete masonry units, and in ETABS, this was now mapped to 4,000 PSI, right? So most of these are basically just a review of the mapping changes that were made as part of the download. Click OK, and we are done. There is our one-way translation from our Revit file across to ETABS. You'll notice that our geometry is all nicely connected and repaired as we made those changes inside of the Revit file first. At the same time, just point out that we did capture all those properties and recreated them appropriately in ETABS. So we have all of our concrete properties on the bottom, all of our steel properties for the objects above. And it is worth looking inside of here to check out the frame sections. And you'll see that Konstru created a new frame section called 24 by 24 that did not exist in ETABS previously. And we can go review it. So it's gone and made 24 by 24 is the property name. It's assigned the 4,000 PSI material to it. And it's actually interpreted the dimensions from Revit and also made the section depth and width appropriately, right? So this is an example of Konstru being allowed to create new properties in your model based on properties from a different file. Okay. So ETABS model, wonderful. One-way translation, great. Saved a bunch of time here and not having to rebuild this model multiple times. We inherited all the properties from the Revit file. Wonderful. The next step here is really to concern ourselves with a round trip translation. But before I do that, we'll just see if I can answer some chats in here. It is not typical for that model preparing to take that long, particularly if you're using the Revit file that I provided. As I said, it can be based on your local internet connection. So depending on your local upload speeds, it may take a little longer. Same issue with the demo model. Well, yeah. Let's just say that on my machine, it's, I'm connected in the office here, so I've got very high upload speeds. It's reasonable to, the times I'm showing here are quite fast. It could be a little longer, depending, like I said, on your local internet speed. So, one-way translation. Reasonably simple to understand. There are obviously some steps there to be aware of along the way. The connectivity of your Revit model being the first thing to be critically aware of. Beyond that, understanding that there are differences between the properties of the objects between different files. So our Revit materials, etc., may not match up ideally with our ETABS materials. Okay, so the next thing I want to move forward with here is the ability to make a round trip. And this is sort of the true promise of Konstru, where I model in one platform, I transit to another, I make changes, I bring them back, right? So let's make a couple of changes here, and this will give us a chance to review filters in particular, and how we can use filters to ensure we're only capturing information we want from our changes. So in my ETABS model, what I'm going to do is I'm just going to select this column over here, and we're going to change its property. So I'll change it from the 30 by 30 that Konstru built, and we'll make it an 8 by 31, right? Just so it's very clearly quite a different column in that corner. I might do the same with this one. We'll change it to an 8 by 31. So we've made two changes in ETABS. We've updated the profile sizes on the right side there with new sizes. And the goal now is going to be to bring those sizes from ETABS back into the original Revit file. So to make an update, I'm just going to essentially launch Konstru again from inside of ETABS. We're then going to choose the original model that we uploaded to. Repair Analytical. And we're going to, in this case, update using the recommended filter. But you'll notice that we're going to see some interesting things when we do this. So we next have, because we're creating a new version of the model when we upload here, Konstru wants us to give it a title. So we need to make sure that we name our version so that they'll actually have a name in the history, the steps. So we'll do 2x column profile changes, right? So updates the 2 column profiles. Date Konstru. Okay, so what we see now is a review interface that looks quite a bit different than it did before. Again, the review interface is designed to tell you what's about to happen to my model. In this case, what's about to happen when I update Konstru with this changes that I've made in ETABS. The first thing you'll see is, well, this looks rather strange. Why do we have 13 deletions? Why do 15 things need reviewing? Why are 124 objects being updated? And why are new objects being added? Konstru will let you know what's changing here. If I click on this updated and I click on profile, or I click on, it's saying for this column, both the material changed and the profile changed. For this column, the material changed. Well, why did the material change? Well, that's because we mapped it. So currently in ETABS, the column has a material called 4000 PSI. we do not want the ETABS material 4000 PSI to be brought back into Revit, right? We only made that change, that mapping, to make sure that the ETABS model had an accurate ETABS material. So this is a case where I do not want the material property from ETABS updating my model, right? I'd rather just grab the profiles in this case. So what I'm going to do is I'm going to use a filter to avoid this change being made to my model without my permission. So I'm going to use the filter menu here. And you can see I have a filter called column profiles. So I'm going to use that filter, and we'll go in a second and review how this is made. But once I use the column profiles filter, you notice that the review interface changes, and now it only shows what I would expect. In this case, the profile changes. The group those are the two objects that were grouped. The groups are not too relevant to me now. It's really a case of the profile and profile changing. So this was a case where it was previously 30 by 30, and after this is the 8 by 31. So those are the changes that I made that I want to capture. And you can see this is really being facilitated by my ability to choose between which filter is being used. The recommended filter is making changes I do not wish. So column profiles gets me there. So let's look in more depth now at filtering and how you make filters. So the first thing to notice is we have a couple of little buttons here. You are able to launch directly from the review interface the filter settings. Filter settings are controlled and maintained on the web app. So by using that button from ETABS, I got directly to the filter settings, which are here, but you can also find the filter settings if you go to the Visualize Elements dropdown, Other Settings. In Other Settings, we have Filter Settings. And you can see this is my list of filters. Now, for those new Konstru users, you are going to have only the recommended filters. Or your list may look very small until you click this button, Show Konstru Filters. And now you will see all of the recommended upload from ETABS, the recommended download from ETABS, etc. Essentially, we have a recommended upload and download filter for every one of the software that Konstru links to, except Excel. Excel does not require any filtering because it's more of just a tabular view of the entire model. So if we look at the recommended download to ETABS, we have two options here. We can view this filter. We can also clone it. So first of all, to understand what's in the Konstru to ETABS recommended download, let's view this filter. So the name of it is recommended download to ETABS. There's a description here. The checkbox, this is the default. We'll make sure that it is the default. And you now have basically every object type that Konstru reads and writes has a set of properties: material, profile, name, geometry, and custom. And what this menu is designed to do is to show that in this particular filter, area objects are allowed, and the material of the area, the profile of the area, the name, and the geometry will be downloaded into ETABS. So all of these properties will be used. There are some instances you can see here where in the recommended download to ETABS, cable objects have been ignored. So this checkbox has been added and cable objects will not be downloaded at all as part of this download. So you can sort of see that each object type can either be ignored or allowed, and then uniquely each attribute inside of the object has the ability to be edited as well. So that is the recommended. If I wanted to take this and make it my own, I would clone it from Konstru to ETABS. Let's make one of ourselves. So let's say floors and columns only, for example, or floors and column no names. All right, so I'm making a new filter here called floors and columns, no names. I'm going to create. That new filter has been made. I'll search it. Floors and columns, no names. Here's my filter from Konstru to ETABS. I can then edit this filter, and I'm now able to make choices, right? So floors and columns means in this case, I'm ignoring beams. I'm ignoring braces. I'm bringing the columns and the floors. We'll ignore the areas. And in this case, I do not want the name. So I'm just making sure that box is unchecked, right? If I have this checked, the name will be part of the properties that are uploaded. Beyond just sort of the basic properties, the material, basic default properties, material, profile, name, and geometry, you also have the ability here to add in any specific attributes that may be present that you wish to exclude. So this is very useful, I guess, specifically for Revit, where you may have parameters in Revit that are being adjusted that you do not wish to be adjusted, that are not material, profile, name, and geometry. They can be added here to prevent changes to those objects happening as part of the download or upload. Okay, so that was what we made ourselves. Here's one I've made already, column profiles. This is from ETABS to Konstru. Let's have a look at this, first of all, the column profiles. So basically, it's allowing areas, it's ignoring beams, braces, cables, floors, grids, levels. It's ignoring most object types, basically. It is allowing columns, and specifically, it's only capturing the profile from the column. So it's being sure to ignore any changes to material that might have been made, possibly via mapping, for example, or name. So this particular filter is very specific. It's column profiles only. The description is no materials, levels, analysis, other objects. So this is where filters are created. This is where the Konstru filters exist to begin with. And as you can see, just from my list of filters, some of the things I've got, right? So all on Revit to Tekla. Beam, brace, column profiles only. Revit to Konstru with no loads, right? So these can get very custom, depending on what your goal is for the upload from Konstru, and depending on what your aim is for future updates from Konstru. So understanding that I've now got, understanding why this is changing, right? So the recommended upload is capturing more than I want because I made changes during the download based on mapping to get the ETABS model up and running. Now that I'm in a world where I'm needing to round trip bring information back, I need to be much more specific about what properties I'm capturing from the analysis model to bring back. So with my column profile filter, I'm making sure that nothing but those changes are what's made to the Konstru model. So looks good, proceed here. And I have now updated the Konstru model. So I'll jump back up there. You don't have to click view model each time. You can just, it just told me that I've got a new version of the analytical model here. So we'll go back to visualize elements. Push this. Okay, so here is our updated model. You can sort of see that our 8x31 column changes have been made, right? These were the thick columns before. But one of the nice visualization categories that we haven't quite looked at yet was the second one down, which is visualize by change. So what this mode allows us to do is we now have two versions of the Konstru model available. We have the first upload, which we made from Revit to Konstru. We then have the update we made from the ETABS model to Konstru, which means we can compare the original to the first upload, sorry, the most recent upload to the first upload, and Konstru can show you what changed, basically. So what it's telling me here is that for the objects in orange, something changed. I can click on this object and it will go in and actually give me the ability to understand what actually changed. You can actually make a PDF report from this if you like. but clearly this can be quite useful to understand what changes have been made from the ETABS model back to Konstru. Technically, we don't need to actually review the changes here if we don't want to. We could go straight back to our Revit file. Close that as repair here. And we can launch Konstru again. I'm going to choose the original model that was created and updated now from the ETABS position. I'm going to download to Revit in this case. Again, I'm going to get a review interface that's going to tell me what's about to happen to my Revit model. It's a lot of updates, more than I would have expected. Column rotations are going to change apparently here. Let's do a slightly different filter. The mapping interface is not going to be as important to us on the way back because most of the materials here are going to be recognized from the original model. I will say that you will notice that the interface is a little bit different than it was in ETABS because we have more object types to be concerned about here. So walls and floors are differentiated. Adaptive components is a possibility here as well. I should also say that we are able to map to any existing Revit parameters. So on the right here, you'll see all of the available Revit parameters, and it is possible to make an existing Konstru parameter map to that exactly. Okay, and our updates back to the Revit model have been made. Now in Revit 2023, there is a slight there's a slight update now to Revit 23, previous than before. Under the Manage tab, or actually no, it's under the, to remind myself where it is. There's one final step we need to make here to actually update the physical model with changes from the analytical model. Really just forgotten where that button is. Okay. All right, so that was a Revit round trip to ETABS, including repair, as well as some mapping and filters. The next round trip I want to focus on is in the other direction. So that was a Revit to analysis translation and sort of pointed out some of the pitfalls involved with that and the need to sort of understand the materials and the profiles very specifically. The next move we're going to make is from an analysis model into Revit. And we're going to introduce here the ability for Konstru and Excel to work together to enable engineers to do some value editing to analysis results before you actually get all the way back to your Revit model. And we'll probably take a short break after we finish this this demo. It should be a little bit faster, I think, than our first example here. So I'm going to reduce both the ETABS and I think I've already got a sub instance open here. Right. I'm just going to open the sample model that I provide you guys. It is very, very simple. It's basically just a grid brace frame with some loads attached to it. So the simplest possible SART model you can imagine, created using the default template. I guess the only thing to note here is I have actually applied a load combination to the model, as well as some basic loads. Let's just do. Good. So essentially, we're generating ourselves a SARP model that has some analysis results in it, right? That's our goal here, to create an analysis model, add some information to it, and then use Konstru to extract that information across and create a Revit model from. So this is sort of pointing out the more metadata focused benefit of Konstru. So going from Revit to analysis is great because it builds the model for you. Coming from analysis to Revit is more about the information attached, about the forces, etc. So the goal of this demo is just to show that Konstru is more than just geometry. It also includes a lot of attributes, etc. So again, the first step in a translation is make a container. So I'm going to jump back to the web app, create a new model. We'll go SARP to Revit with stop in Excel. AECtech demo. So here's my container model. I'm going to jump back over to SARP right now. I'm going to launch the plugin. Again, it's basically the same thing as ETABS, adding the plugin, pointing at the right folder, and then you'll get the same interface as before. And here I'm going to choose the model that I just created and upload the SARP geometry as well as any of the analysis results that may have come with it. I'm going to use the recommended upload in this case from SARP. We're going to update Konstru. And in this case, when we're uploading from an analysis model, this sort of review interface, again, has some very important checkboxes. So Konstru has recognized that we're in an analysis platform and that there may be results that we wish to upload in terms of the shear, moment, torsions, etc. So unless I check this box, Konstru would not upload those forces. So you have to make sure, first of all, there needs to be a load combination set in the model. We can only upload forces from one combination. We don't do enveloping of forces with Konstru. So I've set up a combo 1, and I want to make sure to capture those analysis results as part of this upload. We'll update Konstru. It's reading the model. It says, I'm about to upload 96 new objects, grids, columns, beams, nodes, restraints. Again, some of those things will be filtered out because the object types are not supported, and you can alter what's being uploaded by changing the filter at this point as well. But let's just use the recommended. Looks good, proceed. We can go view the model if we want, have Konstru launch the web page and open up that model specifically. And here is our SARP model. So very simple, just a frame with some restraints and grids and bays. But what we can do here is we can do visualize by attributes, and you'll start to notice that we have those forces have been added to our objects. So we could start looking at the model by those forces, start coloring it by those forces. But again, our goal here is really just to know that when we uploaded from SARP, we were able to capture those force results as part of the upload. So each independent object has its own set of results that have been uploaded by Konstru. Okay, so let's say our goal here is to we need to share a Revit model with the architecture client because that's what the software is. And we want to have our force results appear on a Revit parameter, for example, taggable on a page. We know that the data that we get from the SARP model probably is, we'll call it raw analysis data. And there may be a need for us to do some factoring or rounding to those values before we get into Revit. So these days it is possible to do a lot of that change, make a lot of those changes directly inside of Revit. But I want to point out how we could use Excel to achieve this, right? So I'm just going to launch Konstru Excel instance here. Well, it's just Excel really, and then download the Konstru model into it. And what I'm going to do is I'm going to create a new parameter that allows me to factor around an existing Konstru parameter. All right, so here's my blank workbook. I have Konstru installed for Excel. I'm going to launch Konstru here. It's going to give me a list of all the models, just like every other software. And I'm going to choose the specific SAP model. So SAP model to Revit with a stop in Excel. I'm going to download to Excel now. And again, the filtering isn't really that critical here because, as you'll see, everything's allowed, basically. What you get now is a full tabular view of the model, right? So here's my Excel spreadsheet. I've got the Konstru tab up front showing me all the object types that are available. And then if I sort of scroll down these tabs, materials, profiles, load combinations, load case, load patterns. Again, every non-out cell you could change. If I wanted to change the name of the levels, I could type new values in here. But what I'm really focused on is the beam attributes. So here's the beam table. We've got the location, the closest level, the group, the name. Again, if you wanted to make changes to the names of the objects, you could. But what I'm focused on is the fact that down the end of this table, we have picked up those force values, right? So P start, shears, moments, torsions, and the results, numeric values from that. If my goal here was to download this model into Revit, there are two things to be aware of. First of all, Konstru will make new parameters in a Konstru object for all of these values. So all of these values will be downloaded directly to Revit if you were to download this model right away. When Konstru does that, when Konstru downloads into a new file, generally speaking, Konstru will make a new set of parameters. So in this particular W wide flange framing, you'll notice that there already are a couple of Konstru parameters because I've used this file before, but we will create a new set of parameters under data that includes things like the Konstru ID, the Konstru name, and possibly some of the force values that were created from our SAP file. We think of them as, like I said, raw analysis results. In Don Tomasetti's case, the tags that actually show up on the page in a printed drawing are generally a separate set of tags. So in this particular beam's case, we have some parameters that will be tagged called, let's say, start factored vertical shear, right? This is the value that actually would end up on the page. What I'm going to do is I'm going to show you how with Konstru you can still write to this specific parameter, start factored vertical shear, but you can include that factoring as part of the Excel. So start dash factored vertical shear. What I'm going to do here in Konstru Excel is at the end of the beam table, I'm going to make a new column. And I'm going to call that new column the exact same name as the Revit parameter where I wish that value to end up. So in Revit, as you saw a second ago, there is on that particular beam a parameter called start factored vertical shear. There's nothing in it currently. And my goal is to essentially put a little formula in here to refer to the start factored vertical shear analysis results and do some rounding to it, right? So what I'm going to do is put a little formula, say equal, let's just do round up. Well, actually, my Excel skills are a little bad. So equal to this cell, V2 start, rounded up to 2. No, sorry, my Excel syntax might be a little off here. Pretty sure.
ceiling is one you can use,
Ceiling, you like ceiling better? Let's try that. O2 ceiling.
or ceiling at the start, maybe. Yeah.
Ceiling of the V2 start. Okay. No?
And just give it like 1 or 5 or something.
Okay. It wanted the, yeah, significance. All right. 1. Thanks for the Excel help here. So the ceiling here is going to be 0, I think, though, no? Because the numbers are negative 0.2.
Oh yeah, you can do floor instead of ceiling.
No worries.
You can
Slide
also
down.
do the absolute value.
Yeah, we could convert it to. Well, this is all going to give us negative 1s. Yeah, that's not that fun. I'm going to try the round up. Round start shears just to 2 decimal places. Pretty sure that's, yeah, okay, 0.26. That's a cleaner looking number. And we'll apply that to all beams, right? So all factored vertical shears have now been rounded to 2 digits from their original 10-digit sub instance. The key here is this new column is a new parameter as far as Konstru is concerned. So this parameter did not exist previously. We're adding a new parameter, which is based on an existing value. And the sort of technical part is by naming it correctly here, when we go back and create a Revit model from it, we should get that parameter written directly into where we wish it to be, which is that start factored vertical shear. All right, so let's just make a new model for this. Download, new project. Imperial template. All right, so we've made a new column. We've given it a value. Let's update Konstru with that new. So we didn't make any changes to the data, really. We just did some work to factor and round, or round up in this case. Thinking, it's thinking. There's our original model. We're going to update Konstru now. We're expecting updates, right, to 46 objects, and it should all just be mostly our beams that are getting the update to them, which is that new value. So looks good to me. Click done. We can go view our model. There's a new version of it here. If we refresh, it'll give us that new version. And the reason I'm just going to show the model is just to point out that we have made a brand new parameter that was not there previously. That seeing it there, but let's just have a look in Revit. Here's my new blank model. Yep, okie dokie. Launch Konstru. Download to Revit. Same as before, we're going to get our review interface, what's about to happen, what objects are going to be created in this case, nodes and restraints filtered out by the default. You can sort of see what filters I might have previously used. Beam and column brace profiles only, attributes, etc. So again, filters very critical, can need to be very complicated in some cases to get the results you're looking for. Right, so the mapping may be relevant. We came from SAR, right? Do we want a material in Revit called A992FY50? Probably not, which in this case means we may want to go in and map the material coming from the SAR model to an existing Revit material. The profiles are in the same boat. So we have FSEC profiles, which is the default that came from SAR. If we wanted to, we could assign the 14 by 26. Again, this list here is going to show you only those objects that are loaded into Revit currently. If, for example, this was a very limited set, I could stop the Konstru transaction. I could go back to Revit. I could load in a bunch of families and then rerun it. And I may get much better results here in terms of what's available for me to use, or even the mapping, right? If you load in the whole HSS and W libraries, then you're pretty likely to find a match because the names are going to be very similar there. We've got our column sections, and down the end, we have our parameter mapping. And you'll see here that my start factored vertical shear has been mapped to start factored vertical shear because that name already exists in the file. So I would have had the choice here if I'd named it incorrectly in ETABS, if I'd given it an incorrect string, I could manually make the assignment here at this level, but by naming it correctly, I've sort of automatically made sure it's going to end up in the position we wish it to. Okay, and we have our model inside of Revit. You'll notice here that our parameter factored vertical shear has picked up that rounded 0.26 that we did in the Excel. And again, that addition of that value into this cell was based on the fact that we added this column, right? So our goal there is just that we don't intend Konstru to translate raw analysis results directly into Revit. We sort of expect the user to have an intermediary step. You'll notice in this case that all that data has been added to the Revit objects as parameters. So this is the original data, the unmodified version of it. We do a little bit of rounding, as you can see anyway, as part of the values that we'll display. But the fact that this value ended up here, and in this case, as far as Thornton Tomasetti is concerned, this is what would get tagged on the page. These values are not intended to get tagged on the page, right? Because they're directly from SAP. It's showing you the combination and then giving you the values for each. Okay, so two one-way translations with a little bit of a round trip in there, showing you how to go from Revit to analysis, how to go from analysis to Revit with a little bit of Excel in the middle. I think at that point we'll take let's call it a 5-minute break. We have about 55 minutes left. Let's come back at 12:10. So we'll call it 6 minutes. And we're going to move on to next model merging, which is a sort of slightly different theoretical way to use Konstru. And then we'll round out with some of the Grasshopper files. I'll try and answer some of the stuff in the chat during this break, but stretch your legs. I'll begin again at 12:10 Eastern. All right. Okay, welcome back. The other critical Konstru workflow I want to talk about today is what we term model merging. The goal of model merging is basically to prevent markups, the creation of documents that describe information for somebody else to manually input into another software. This is for structural engineers, mostly apparent with analysis results. So I just showed you how to get some forces, etc., from SAP into Revit. For a software like RAM, this usually means information such as studs, camber, profile, etc., etc. And our goal here is to be able to compare two models and then extract information from one and add it to another. The demonstration I'm going to show is basically allowing metadata to move from one model to another. But model merging is far more than that. You could actually, you could move, let's say, a tower model onto a podium model and have them be merged together into one file. You could take one SARP model and add it to an ETABS model and extract from the SARP model all of the loading, etc., that's already present. So there are lots of different ways to do it. The most time-saving and useful one we've found is the ability to compare analysis models to Revit models for the purpose of adding structural metadata to the Revit file. So if you're designing in multiple software, how do I get my studs, camber profile, all that stuff into the Revit file and tagged on a drawing? So that last little demo from SARP to Revit showed you that Konstru is able to read analysis results. It's also able to write to very specific and custom Revit parameters. And the model merging workflow is sort of an extension of that. First time we did this was on Tower A, an older project here at TT, where there was an existing SARP model that was being used for column design. And there was an existing Tekla model that was being used, for fabrication level detailing. This was long before Konstru was sort of used. So these two models were built independently and sort of completely by hand by engineers in terms of SARP and by the steel detailers in terms of Tekla. At some point, though, you need to get the Tekla model having the same information as the SARP model design, right? So what we built here was a means of comparing the two 3D models, finding matches between the two models, and then for objects that are found to match, allowing the user to translate information between those matching objects. So upload, a beam from SARP and a beam from Tekla. As long as they share generally the same XYZ coordinate space, you should be able to find a match where both start point and end point for one beam are within tolerance of start point and end point for another beam. After you've found a match, you basically update the original model with information from the analysis model. And the end goal of all this is to basically automate the creation of these types of drawings. So where there is a lot of technical textual information required to show in a structural drawing, and it's been generated by an analysis platform, Konstru can help you automate that process. I think we saved about 3 weeks worth of time here on this particular project. Okay, interest of time, I'm going to lean on a video a little bit for this one, but it does go through the process in depth and should be fine for today. So this demonstration is going to be specifically about a RAM model and a Revit model. But as I said, any two Konstru models can theoretically have this process applied to them. Okay, so model merging. As I said, basically the process in this case is going to be how we get a RAM model, profile, studs, and camber and forces from the RAM model into Revit. It's going to involve 3 steps. First step is going to be related to sort of what we've demonstrated already with Konstru, and we're going to upload from our local model to Konstru. So there's a Revit model, there's a RAM model, we're going to upload both. We're then going to use the web app to compare and merge data, and finally we're going to update the Revit model with information from RAM. So we're going to make the containers first, right? Whenever you use Konstru, the first thing you have to do is you have to make a place for things to go, and this is done via the web app. I'm making one here called Revit model to merge with RAM. I'm going to make another one called RAM model to merge with Revit, right? So one container for each. With both containers made, I'm now going to open up a Revit file, which is where I have the drawings for this particular project. In this case, in this demonstration, I'm only going to upload a single floor plate from Revit, although it would be possible to do the whole floor, but just for this demonstration, for this video, I'm going to upload only the structural framing from this floor. So what I'm doing here in Revit is I'm turning off all the object types I don't need. I'm just making a drag selection of all the framing. Now I could have used the Konstru filter to do this, but in this case, the drag window is just as fast. I'm uploading to Konstru the objects. And I think the key thing to note here is I'm not concerned at all about analytical versus physical geometry here. The Revit model is where it is, and the RAM model is where it is. There's no sort of need to be concerned about the connectivity in Revit because the RAM model is already built and designed. So I did not check that box for analytical position of geometry. I do want to use the active selection. So I'm using that box there where I specify that I want to only upload the objects that I have in my selection. And I can review the model. Again, this was a selection-based upload, a single floor plate from Revit. There it is. All right, so RAM is next. RAM's a little bit different than most of the other Konstru platforms. Konstru will run as an EXE. So once you've installed Konstru, you'll notice that most of the Konstru plugins will be run from inside of the software. There's a tab in Revit. There's a toolbar in SAP. For RAM, it's different. We have an EXE, an external application. So once installed, you'll go to your start menu. You'll type in Konstru and you'll see konstruram.exe. It's the same interface. You first of all need to choose a model to upload to. And then I'm going to make sure, just like I did in SAP, that I upload the reactions, because this is where the juice is here. This is the information we want to end up in Revit. So we're being sure to upload the reactions with each member. RAM doesn't allow, and then in this case, we go and point directly to the RAM model we want. So this is me saying, I want to upload that RAM model. RAM is a little tricky in that it does not allow us to do a selection-based upload. So we can't upload just a single floor from RAM. We, in this case, sort of have to upload the whole model, but the comparison and merging should be able to deal with that issue for us. So there's a lot more objects in the RAM model because it's not just a single floor, but the key is that it's got all the data we need. So there is my RAM model. Okay. So the next step we're going to do is we're actually going to launch the compare and merge interface. This is done by the web app. And I will show an example of this live in a second, but I'm just going to use this video first. So my goal is to add information from RAM into Revit. I'm going to open up the Revit model to merge with RAM Konstru container. That's sort of my first step here. There. So there's my single floor. I'm then going to launch the compare and merge feature. So this is a feature from the drop-down menu where visualize elements usually is. You'll see something called compare and merge. What then happens is that Konstru is asking, from which model do you wish to merge changes? So in this case, I'm actually going to specify the RAM model as this drop-down menu. And what Konstru will do is it will overlay the two models in 3D space. So what you're seeing here is the orange objects. Those are the objects from RAM. The objects in gray, that's the single floor from Revit. This is an instance where, in this particular case, one of the idiosyncrasies of using RAM is that RAM does not have negative coordinates, as in there is no below zero as far as RAM is concerned. Obviously, in every other platform like Revit, you have basement levels below zero. When you translate with Konstru from Revit to RAM, we basically pick the whole model up in space to facilitate the creation of the RAM model. What that can lead to is sometimes you get vertical discrepancies, right? So even though this particular project did use Konstru to make the original RAM model, because we lifted it up, the Z-axis is out of alignment here. So the Revit model floor is at a different elevation than the RAM model floor. You can use the interface online to sort of review that by showing you the grids and levels tags and figuring out what the delta is between that elevation and the other elevation. And then most critically, what we allow for you to do here is you can actually transform the models. So we wouldn't be able to find a match for this beam because its corresponding match is way up here, some distance. So what we're going to do is we're going to move the RAM model down by a fixed Z elevation, which we understand, to put it in the same coordinate space as the RAM file. So I know that this is about 300 inches. I'll move it down, and now the two floor plates are in alignment. And we can move forward at this point with the comparison and the merge. So once you've got the two models sort of in the right position, the next thing to do is to configure what's going to happen via this merge. The first thing we can specify is the tolerance. So how far from the start point of the Revit beam should you look in the RAM model? Obviously, if the two models are exactly the same, you could have this at 0 or 0.1, but we're at about 12 inches here because there may be some differences between the two models. The next button we're going to specify is we want to identify by geometry, as in do a comparison by geometry. Do not assume that there are shared IDs as part of these two Konstru models. Beyond that, you'll start to recognize some more sort of checkboxes we saw previously as part of the filtering interface. So in this case, as filtering previously allowed us to say, when you download to ETABS, do not bring these attributes. In the merging, we can make sure that from the RAM model, we do not add things to Revit we don't want. So the critical ones here are the RAM model 3D position, the XYZ coordinates of the model in RAM. We do not want that to come into Revit. So we're going to uncheck the geometry. We do want the profile from RAM and the attributes from RAM. Attributes are considered to be the camber studs and forces. So those are all useful information we want to pull across into Revit. So we're going to uncheck the name. We don't want the RAM name. We don't want the RAM geometry or the RAM material. We do not also want to add any new elements. At the moment in this view over here, you'll notice that a lot of the RAM model objects are green. This is because as it stands currently, those would be added as new things to the single floor Revit model. So we're going to uncheck this box and only update existing objects in the Revit model with information from RAM. There's some other options here where we can make a custom selection. So if we hadn't done a selection in Revit, we could say, you know what, I only want to merge beam objects, or I only want to merge column objects. Now with our settings set up, so identify by geometry, only use a 12-inch tolerance, only update things that you find a match for. What we see in the merge interface is now what would take place in Revit. So every object in orange is an object from Revit that found a match in RAM and is about to have information added to it. And if you click on the object, Konstru will tell you that previously there was no camber information in Revit, and now we've added 1.5 as a value extracted from RAM. Same thing with studs, same thing with the forces. Another thing to note here in the view, not every Revit beam is orange. And so the question is, why is that? So the object over here, I would say this beam here exists in Revit, but it does not exist in RAM. So this is maybe an opening in Revit that where a beam was not modeled in the RAM model. So there is no possibility to find a match here. In this instance, in this region where we sort of have this angled beam and the connections across, in the RAM model, this beam was modeled perpendicular as an extension from this. So essentially, all the endpoints of these beams are beyond the tolerance of the match that we set up. Again, this is intended to be a high percentage match. We don't expect 100% because things like this, the difference between the RAM model and the Revit model framing is entirely plausible, right? So our goal here is to get a high percentage of orange objects that are going to get information from the RAM model added to them. So that once we click merge, we've now got a new Revit model that has a new Revit Konstru model that has RAM information attached to it. And so to sort of close out the loop here, I'm coming back to Revit. Here's my tag drawing lacking that information. I'm then going to launch Konstru. I'm going to choose that model that I just merged. I'm going to download. The mapping, etc., is not critical here because it's all just attributes we're adding. We do see that 90 objects are being updated and one new object is being added. This new object is a group. Whenever Konstru changes a model, it attempts to put the things that it changed into a selection set for the user to grab. So every object that Konstru changed in this download is put into a new group called Konstru Merge Changed. which basically allows you to select after the fact what actually happened to the model. So we'll say, looks good, proceed. And mapping, we're not so interested in here. We just want to get to a point where all of our camber and studs information is added to our page. And here's that group that's created. If I select it and zoom in, you'll see that, you know, everything that had information added, camber and studs, is part of this group. And here are those beams where, again, like I said, in RAM, this beam was modeled perpendicular at this location, which means we are unable to find matches for a lot of those frames. This is the set of information we still, you know, the non-matched frames would still technically require a manual markup process, somebody making a PDF that describes the information and handing it off. As I said, our goal here is that that markup is 10 objects, not 100. Whereas most of the plan has been matched directly with RAM. There's a small percentage that may need to have that comparison done manually. All right, so that's the demo video. I do have a live example I'm willing to show right now, just to sort of prove how it works on the web. So a very simple model here that I've searched for. I'll just do it from the script from scratch here. So I'm just going to search for merge example. Probably quite a long time ago. So I'm opening up, let's say, this Revit model. We can tell it's a Revit model because it's poorly connected. And the real thing I'm trying to show here is that for merging, the connectivity of the model is not at all relevant. As long as we're within tolerance, we do not mind if the Revit model is poorly connected. This process is really designed for at the end stage of projects where, like I said, there's probably a very good reason that the Revit beam has been moved to where it is underneath the slab, etc. So here is my Revit model. It's got some properties, HSS, and what I want to do is I want to bring information in from the SARP model to this. So under Visualize Elements, I'm going to go to Compare and Merge. Which model do I want to merge information from? In this case, I'm looking for SARP for merge. And what's going to happen straight away is the two models are going to be overlaid. So the model in orange is the SARP model. The model in gray is the Revit model. As you see in this case, they're aligned. But if I needed to, I could move them around, right? I could say, actually, I need to move this over by this far to have alignment. In this case, I don't need to make changes. So I can leave these to 0, 0, 0. But you can see here where it's beneficial for the two models to sort of live in the same coordinate space. The one difficulty that's not solved by this translation vector is a rotation. So where a analysis model has a local rotation compared to the Revit file, that is an instance where we would need to bring in Grasshopper to the mix. So I am going to show that, but I'll just finish off this merge example. So two models in the same position. I'm going to go to Configure. Here are my settings. As you can see with these settings, I'm finding matches for all of the objects, but I do not want the SARP geometry to update the Revit model, right? The connected SARP model should not update the Revit model. I don't want the SARP material. I don't want the SARP name. I just want the SARP profile and attributes to be merged. I also don't want to add any new objects. I only want to update the existing objects in that model. So 12 updates, that seems about right because these are the things that are going to be updated. I click merge, and at this point, I've now added to this unconnected Revit model. You'll notice how none of the frames have moved, but they have now picked up analysis information from the other model, right? It even actually picked up that factored vertical shear that we had previously. Okay, so that process is merging, very, very useful for sort of end stage of projects where you got a lot of data from one, you need to get into the other, and it can really help you make your Revit drawings a lot faster than otherwise. Okay, so for instances where you need to rotate, right? And the benefits of merging are so great that it can be useful just to have things in the same position no matter what. And this is where Konstru Grasshopper comes into play. So what I'm going to do now is introduce a couple of basic Grasshopper scripts and then show you how you might use Konstru Grasshopper to move a model into alignment with another model for the purposes of facilitating this data transfer. All right, so I'm going to launch Rhino now, and I've got a feed-based Rhino units here. You don't need any files for this besides the Grasshopper files I've supplied you. And let's just have a look at a couple of those. So there is a big list in this folder of Grasshopper files. Let's start with a very simple one, create beam, and then we'll move all the way up into create a full model with loads. So at a very basic level, what Konstru Grasshopper allows you to do is essentially define a center line for an object and then create a BIM beam from it, right? So in this case, what you see on the screen is this is a Konstru create beam component. So once you install Konstru Grasshopper, you will have this full set of components which allow you to do three things. You can create elements, and you can create pretty much all of the things that you've seen today, you know, model objects, as well as analysis objects. So you can create loads, load patterns, links, releases, etc., restraints directly from Grasshopper. This is how we upload from Grasshopper to Konstru. We create elements. The other option you have here is you have the ability to get elements. So this is essentially saying from an existing Konstru model, I want you to download those objects into Rhino Grasshopper. We also have a model set of components. This allows you to download specific models, select models you wish to download. Well, for example, let's say I wanted to download that the model that I uploaded today, right? I wanted to get all the beams from the model that I uploaded today. So what I'm going to do here is I'm just going to launch the Konstru select model. I'm then going to choose from my available models, which is going to include the ones that I worked on today with you guys. And at that point, I can basically take all of that information, let's say this one, and it can now be, we'll actually get elements from the model. This model, download these elements, and you can see what we have now in Grasshopper is that file that we worked on, right? So these are currently just being previewed through the component. What we do have here is all of the information that was used to create it. So when you download a Konstru component into Grasshopper, you're going to get the profile of all those objects. You'll get the centerline curve for all those objects. You'll also get the name, if there is one, rotations, justifications, all of the fun Revit parameters are available to you here. At the same time, we will actually give you the closed geometry as well. So if you need to sort of make a Rhino model from any of those other models, you can download the geometry. And at this point, you have basically a Rhino model, right? So these are all now Rhino objects, Rhino beams that we could mess around with in here. So we can download existing geometry. We can make geometry here and upload it to existing models. We also have the ability to visualize results, right? So let's take an extract and visualize results file. And what this allows us to do is to download any existing Konstru model. So in this case, we're using select model, download all the beams from that model. And we can also now extract all of the forces. So all the frame results from that model can then be visualized directly inside of Grasshopper. So in this case, I believe we're looking at, P's. We could look at the vertical shears, moments. Again, just the ability to take information, objects from a Konstru model, decompose them in Grasshopper and do something interesting with it. The other example I'll show here is a full model creation. So you can make basically everything. So this, I'll just review this quickly because it's more going to be for you to take home to see how it works specifically. But this example file will show you how you can, first of all, build a small little parametric building, which includes, let's say, floors, some grids, some exterior panels. And then in this case, use Konstru to make those objects for another platform. So from a base curve, in this case of the walls, we can create a set of Konstru grid lines. From the floor surfaces, we can create a set of Konstru geometry elements. In this case, we're creating a set of levels by a Grasshopper. We're also making a set of area objects, adaptive components for the panels. We're making column objects. We're making beam objects, floors, walls, etc. And all of this is tied to our original script. So if we were to add, more floors to the building, 5 floors, less floors, we could increase the total height. And all of this is updatable and sendable to a brand new Konstru model. So as an example, I'll go up to Konstru, we'll come to models, create new model. We'll say this was a Grasshopper, create tower. Make this a little taller, make this 6 or 8 floors. Okay. And at the end, we're collecting all of our things together. So we've made floors, we've made walls, we've made areas. I don't know why these are not being collected. At the same time, we've also worked to create the analysis objects we need. So down at the bottom here, I'm showing you how you can create restraints with properties directly inside of Grasshopper. So all of our nodes, once they get to analysis, will be restrained correctly at the column bases. We can also apply loads to our beams directly, as well as load patterns, floor loads, load cases, and load combos are all possible to create directly inside of Grasshopper. So all of those are being collected together. I'm going to then just choose the model I created. I'm here on the internet, and we'll add our information to the GH created tower. So I've chosen that repository to send information to. In Grasshopper, it's a component called upload to Konstru. You need to give it a set of elements to upload, a message, first commit, and then click a button. Once you click the button, you'll see the same interface as before, review interface, which objects are being uploaded. There is no filtering necessary in this case because we're sort of grabbing everything from Grasshopper. Looks good, proceed. Go view the model. There's our tower with our floor plates, our panels. We should be able to also see that we included a lot of our area elements and load patterns and load cases. We can also hide things that we don't want to see here. So if we didn't really want to see the areas, or the components in this case. Geo elements. All right, let's turn off that geo element and just check out the model. So again, you can see that in the view here, it is showing or visualizing the fact that there are loads being added, line nodes in this case, to all those objects, and they would appear or be created as such in the analysis model. Okay, the last grasshopper sample I want to show is the example where we talk about movement, because as you've seen, whilst the model merging workflow can be very beneficial, having the two models in the same coordinate space is sort of the prerequisite of that approach. And there'll be a lot of projects where the analysis model will be at the origin point and the Revit model might be, 10 miles away. So I've also created an example file here in the folder I've shared that should enable you to move a model across. So there's an example here, Konstru downloaded and move a Konstru model. So essentially this script is going to show you the download process, but then also the ability to actually translate a model using Konstru. So what we have on the front end of this set of components is your basic read a Konstru model, extract all the elements from it. Canvas. I'm sorry, I might need to relaunch Grasshopper here. It's acting a bit weird. Not allowed to select anything on the Grasshopper canvas. 1 second, I may just restart this. Whilst I'm bringing up this Rhino model instance again, are there any questions out there about the model merging process I've shown that I could answer? This is open. Okay, sorry. File again. Download. All right, I can grab on the canvas. Okay, so what we're doing is we're downloading a model. You can see here, it's basically that file that we saw previously. We can download the model directly into Grasshopper and have it here in front of us. And what we're going to do to move this model into a different position, we are going to extract the key geometric element from the object, and we're literally going to transform it. We're going to apply a move to it. So the first step in this process is to download the model you wish to move. The second thing that I've done here is inside of this Rhino model, I've set up sort of a position where it's moving from the original position and the position where it's moving to, just by drawing a curve on the ground. I've referenced those two curves in to give me a translation vector. And I referenced the other curve in here, these two curves, to give me a rotation vector. And again, this is something we're happy to help people with if it's sort of complicated and needs something specific. But essentially then at this point, I'm moving all of the Konstru objects into a new position over there based on the vector that I've assigned, right? So this movement, that rotation, move all these objects over there. Finally, what we have here is the ability to update an existing element using Konstru Grasshopper. So take this element, don't change its name or its profile or its material, but I want you to use a new position for the base curve. In this case, this is all of the framing objects have now been moved over there. So download the model, apply a translation, update the elements, and now we have a new Konstru version, which theoretically should be in alignment with whatever Revit model we wanted, right? So if I enable these objects, I've updated the position of the Konstru objects, and the last thing is to actually send that update to the original model, right? So clicking this here is then going to make a new version of the Konstru model with updates to the position of the objects based on the vector and rotation that I have assigned in Rhino Grasshopper. So this is sort of, it's if you find yourself in a position where the two models have a rotation issue, then you'll need to jump to Grasshopper. If it's just a translation, if it's just this one movement, then it should be possible to sort of decompose this vector and use the merge feature, the compare and merge translation, to get the model into the right position. You can also, pretty much any two models can be put into the same theoretical space, right? So you can choose any of the models that have been made and sort of have them appear in the same theoretic space. This one, we've got a much smaller file on the inside of a much larger one. That's entirely possible. We've got 10 minutes left. So, question, does RAM model need Excel edits? Question was, does RAM model merging to Revit need Excel edits? Technically, yes, simply because it's raw data from the RAM model being sent to Revit. Now, it's possible for things like number of studs and camber. You don't need to do much factoring or rounding to those values because RAM usually does a pretty good job of hitting the studs you want. But certainly the key here is that the data you get from RAM is raw. And yes, there may be a need to modify it before it gets onto the tagged page in Revit. As I said, the key there is that Konstru does not send information to the tag page automatically, right? We always sort of have an intermediary step, where in this case, you can see we will put that information here, and theoretically, you could do the modifications to these parameters and then write them to those values. So whilst Excel is a useful stop, it's not a necessary stop. That manipulation could be done in Revit. Okay. And the last thing I'm going to show today is a little sort of random, but I'll show it anyway. So the intention here is just to get people comfortable feeling like they can bring two models together into any two software, right? So here is this model that I made today from SAP. This is that framing model. If I wanted to download or compare another Konstru model to this, I certainly could download the whole thing. But these days, because we have this new button called Rhino inside Revit, I'm essentially able to do the exact same process that I've demonstrated here, where I download a Konstru model. But that Konstru model can be downloaded now to the inside of a Revit model. This is a little meta, but I'll show you what I mean. So I'm in Revit right now, the model I downloaded from SAP. I'm opening up a Rhino inside Revit instance. From inside of Rhino, from inside of Revit, I'm then going to launch Grasshopper as well. And I guess what I'm proposing here is that if you find yourself in a place where you need to compare your SAP model to a Revit model, you don't necessarily need to use Konstru and upload and do the merging interface I showed previously. You can literally upload your SAP model to Konstru, download it to a Rhino inside Revit instance, and then you have the model sort of overlaid directly with the Revit model. Show that in a minute once we get loaded in here. So we are now in Grasshopper inside of Revit. I'm just going to make sure that I've got my Konstru components here. For most people, you shouldn't have to do this. This is just a me problem. You can ignore this. Okay. All right. So we're inside of Grasshopper, inside of Revit. I'm just going to open up that sample file I gave you for downloading and moving a model, because the download portion is going to be useful to us here. I'm not going to worry about the moving the model at all, so I'm going to leave all that disabled. But what I can do now is choose a Konstru model. Let's say the one that we built earlier today in the Revit file. Download it. Preview all those objects on, right? So this is showing that we can view all of the Konstru model directly inside of Rhino, but we also have the option over here to show that same preview inside of the Revit model. Show up yesterday. So that model there, the red thing in Revit, is a Konstru model. It doesn't exist in Revit. You can't select it. Nothing there. But if you needed to compare your analysis model directly to a Revit model, you can now download your analysis model directly into the Revit environment. And you could do the overlay and comparing here if you wanted to. Technically, we can also directly make Revit objects from these. But I think the key thing here is that the comparison of models, theoretically, you could only previously do it on the web through sort of alignment and merging. But now any two Konstru models can be sort of loaded in to Revit and visually compared. So a little bit of a random one to finish with, but an interesting workflow for the sort of advanced users out there. There's plenty of, any Konstru model at this point can be downloaded and previewed inside of the Revit file. Okay, we're almost at 1 o'clock. I can't believe that took 3 hours. How about that? Thank you very much for joining, everybody. Are there any questions I can address in the time we have remaining?